Hello everybody and welcome to 9.2.5 Applications of the Pythagorean Theorem. So here we're going to be working with even more using a squared plus b squared equals c squared to figure out if it is a right triangle, or figure out more specifically in this section what the missing side length is of one of the legs or the hypotenuse. So real quick, let's take a look at the math notes for squaring and square roots. So when a number or variable is multiplied by itself, it is said to be a square. For example, if I do 6 times 6, it's like I have 6 as one side length and 6 as the other. And when I multiply them together, it's 6 squared, and it gives me 36 centimeters squared. And we see this said here in the math notes below. We do denote the square root symbol as this radical sign. So for example, the square root of 36 would just be the two numbers I multiply together to get 36, which would be positive 6. And now I can move on to the first set of problems here. So we're going to be looking at a bunch of different problems to help find a missing side length. For example, here we're missing the hypotenuse, or side C, you would call it. In this example here, we're missing a different side length. We're missing one of the legs. And same with the problem right below it. So it says Anne is measuring some fabric pieces for a quilt. So we're going to use Pythagorean theorem and your calculator to help her find each of the missing lengths below. We're going to decide whether each answer is rational or irrational. Remember, rational can be written as a fraction like 1 over 3. Irrational is something like the square root of 7, where you can't write it as a fraction. And additionally, rational numbers, they will have decimals that repeat or decimals that terminate. So let's look at the first one here. Well, I know that my hypotenuse, my longest side, is always going to be across from my right angle. So here in these first two problems, I've identified my hypotenuse. And in this problem down here, it's a little bit different. My hypotenuse is going to be directly across from my right angle, so it's down here. And if you want, you can always rotate your triangle. So if you wanted to like draw the picture so it looks more like the ones above, there's no rule that says you can't do that. All right? But you just have to make sure that you put these correct side lengths with the corresponding ones on your new drawing. All right, so looking at the first problem, I like to assign letters to each of these sides. So I've got A as my smallest leg, I've got B as my second smallest leg, and then I've got C as my longest one. So if it's A squared plus B squared equals C squared, then I'm going to substitute in 24 for side A plus 32 for side B, and that's going to give me side C. And then from here I can just use a calculator, figure out what 24 squared is, add it to what 32 squared is, and then from there I'll have C squared. And then when I get C squared, whatever that is, I can find the side length by taking the square root of it. So again, it helps to identify each of the legs and hypotenuse here, and that'll help you with finding that missing side length. All right, looking at 9-123, it says Coach Kelly's third period PE class is playing baseball, and the distance between each base on the baseball diamond is 90 feet. So on my diagram, I'm going to go ahead and write it as 90 feet between home plate and first, 90 feet between first and second, 90 feet between second and third, and 90 feet between third and home, because this is a perfect square, and so it has the same side lengths, and it also has the same angles. And the angles inside of the square are, of course, right angles. And so, of course, we see two right angle triangles here. If you were to draw a line directly across from third base to first base, because Lisa at third base throws the ball to Dano at first base. So Lisa's over here, chucks it across the field. Dano catches it. So how far did she throw the ball? State whether your answer is rational or irrational. So do we see at least one right angle triangle here? If so, what would this side be known as? Is this side A, B, or C? And then how could you use knowing that these are 90-degree sides to figure out what that distance is that Lisa had to throw the ball to Dano. I would come up with an equation over here using a squared plus b squared equals c squared, and that'll help you figure out how far Lisa had to throw it. All right, then we have 9-124. It says, as the city planner of Wright City, you are responsible to report information to help the Board of Supervisors make decisions about the budgets for the fire and police departments. The board has asked for a report with answers to the following questions. Each grid unit in the figure at right represents 1 mile. All right, so here we've got one straight side, and this is a straight side that we can calculate how long it is. It looks like it starts at 7 and it goes up to 13. So I could say that this side is 6, but then these other sides, it's not so easy to figure out the distance of them. So here, let's go ahead and figure out what it's asking and then go from there. It says, for fire safety, bushes will be cleared along the perimeter of the city. What is the length of the perimeter? Include all of your calculations in your reports. All right, so perimeter, I know that's the distance around my triangle. And right now I only have one length. So how do I figure out these other 2 lengths? Typically I have 2 numbers and that can help me figure out my third, but this time I only have 1 side length given. Well, let's see. Looks like there's a right angle here. So this is my right angle triangle, but I only have the 1 side length. So what could you do here to make it possible to calculate maybe like the base or the height of the triangle? Because that might help you get this side length or that side length. All right, think about what you could do here with this drawing to create maybe some more triangles within it, or just create another right triangle in some way, because that could help us figure out one of these side lengths. And then for part B, it says, some people say the right city got its name from its shape. Is the shape of the city a right triangle? Show how you can tell. So I just kind of went up and assumed that this was a right angle, but how can I know for sure whether or not it would be a right angle? Is this in fact Wright City, or is the name misleading? Moving on to 9-125. It says, Clem and Clyde have a farm with 3 different crops: a square field of corn, a rectangular field of artichokes, and a right triangle grove of walnut trees. A fence totally surrounds the farm, so we're going to find the area of Clem and Clyde's land in square miles and tell them how much fencing they will need to enclose the outside of their farm. Okay, so right away, I see that it says total area. And then it also mentions the fence that they'll need to enclose it. So fencing, that's telling me the distance around. And so what word that is not area would represent just what I need around the shape? Starts with a P. And then from there, think about how you can calculate the area. Well, we have, for this first square, the 2 side lengths. We have our base and our height, or our length and our width. So this one should be relatively easy to calculate the area for. But what about the area of this triangle? What's my formula for calculating the area of the triangle? And then over here, we've got 1 mile as a side length for that rectangle. Do I know the side length going across here? Could the triangle maybe help us out? So you're going to use all this information to calculate the area of the entire thing. So it looks like we're going to be adding up 3 different areas to get a total area. And then we're looking at the perimeter. So how can I get these side lengths over here? What do I know about squares, rectangles, and triangles that can help me figure out those missing side lengths? And we're looking at 9-126, and it says Scott and Mark are rock climbing. Scott is at the top of a 75-foot cliff, and when he throws a 96-foot rope down to Mark, the rope is stretched tightly from Mark's feet to Scott's feet. How far from the base of the cliff is Mark standing? Draw a diagram and label it. All right, this is huge in these Pythagorean theorem problems, drawing that diagram. So right now it says Scott is at the top of a 75-foot cliff. So I'm going to draw a cliff here. Typically it sticks out but we'll make a straight edge. And it's 75 feet high, so I'm going to go ahead and draw that. 75 feet high. And then when Scott throws down this rope to his buddy Mark, who's down below, it's really pressed tightly against the side of the cliff. All right. And it's a 96-foot rope that goes all the way down the side of the cliff and lands right here at Mark's feet. There's Mark. Here's Scott, who just threw it over the edge. And so here, how can we create more of a diagram using the 75-foot side and this 96-foot side of the cliff to figure out what the missing length would be? All right, so what is our missing length in problem 9-126? Again, we're using Pythagorean theorem for these problems. Next, we're looking at 9-127. It says Nicole has 3 long logs. She wants to place them in a triangle around a campfire to allow people to sit around the fire. The logs have lengths 19, 11, and 21 feet. All right, so the first question is, with these lengths, can she form a triangle? So if I have 19 and 11, and again, drawing a diagram always helps out. I've got 19 and 11, and then 21 is my longest side. Can this create a triangle? Is that possible? All right, think about what you know about the triangle side length theorem to help you figure this out. And then we look at problem A. It says, can she form a triangle? And we just answer that by justifying our answer with maybe a drawing, hint, hint. And then B, it says Nicole realized that she wrote the numbers down incorrectly. Oh, come on, Nicole. Her logs are actually 9, 11, and 21 feet. So again, we could draw a diagram. If we had 9, 11, and 21 feet, is this possible to make a triangle, or would it not? And then finally, would this shape be a right triangle? So using Pythagorean theorem, would this be a right triangle? Go ahead and justify your answer. And then you're going to finish off here with a learning log. In our learning log, we are going to describe how the Pythagorean theorem can be used to find a missing side length on a right triangle. And we're going to make up examples in which either the hypotenuse length is missing or a leg length is missing. Be sure to include pictures and describe how you would find each missing length. And then we're going to title this entry Pythagorean theorem. All right, so this is all of the core problems for today. Hopefully you guys found it useful in terms of when we would use the Pythagorean theorem, because it will come up. I mentioned how I used it when I was painting the soccer fields. When you're on a baseball diamond, throwing from first to third, it definitely comes into play. And now you can move on to the review and preview. Thank you so much. I really appreciate your hard work and all of your time. I'll catch you next time.